Some moments in astronomy are so dramatic, they redefine our understanding of the universe. One such moment occurred in July 1994, when a comet named Shoemaker-Levy 9 slammed into Jupiter. Welcome to Infinity Beyond, where today we revisit one of the most spectacular cosmic events ever observed. The impact wasn't just visually stunning, it was also scientifically profound. Shoemaker-Levy 9, often abbreviated as SL9, was no ordinary comet. It was massive, so large that scientists estimated events of its scale might occur only once every 6,000 years. And unlike most celestial bodies, this one wasn't intact when it struck. SL9 had been previously captured by Jupiter's powerful gravity, which tore it apart during an earlier close encounter. What resulted was a train of over 20 separate fragments, each following a highly eccentric orbit around the planet. Eccentricity in this context measures how stretched an orbit is. 0 for a perfect circle, 1 for a hyperbolic escape. SL9's orbit had an eccentricity approaching 1, marking it as highly elongated and chaotic. These fragments entered Jupiter's atmosphere over several days, slamming into the planet at speeds exceeding 60 kilometers per second. The impacts created plumes that rose thousands of kilometers into space. Each collision released energy equivalent to millions of megatons of TNT, dwarfing even the most powerful nuclear devices on Earth. What scientists witnessed was astonishing. The explosion scars were larger than Earth itself, dark, bruised blotches in Jupiter's upper atmosphere that persisted for months. Through visible and infrared telescopes, researchers recorded how the atmospheric layers were disturbed and how shock waves spread out from the impact zones. But the real scientific gold lay in what the event revealed. First, it proved that large celestial collisions are not relics of the early solar system. They still happen today. Second, it demonstrated Jupiter's critical role as the solar system's cosmic vacuum cleaner. The planet's immense gravity captured SL9 and prevented it from possibly heading toward Earth or other inner planets. Spectral analysis of the impact plumes allowed scientists to detect molecules and elements buried deep in Jupiter's atmosphere. Ammonia, hydrogen cyanide, and sulfur compounds, normally hidden beneath layers of clouds, were blasted into the upper levels, providing rare insight into the planet's inner chemistry. Additionally, the event sharpened humanity's approach to planetary defense. It served as a reminder of how vulnerable Earth is to cosmic impacts and how vital Jupiter's shielding presence might be. Scientists began to take asteroid tracking more seriously after witnessing what such an impact could do on a planetary scale. The visual record of the SL9 collision also changed public perception of planetary science. For the first time, people around the world saw real-time evidence of space being violent, dynamic, and unpredictable. Schools, observatories, and news outlets covered the event, inspiring a new generation of astronomers. In many ways, the SL9 impact made Jupiter a more relatable planet. Not just a distant gas giant, but a dynamic, active body, engaged in ongoing cosmic drama. And this wasn't just about Jupiter. The lessons learned applied to other gas giants, exoplanets, and impact science across the cosmos. Today, we still study the aftermath of Shoemaker-Levy 9. The event shaped how missions like Juno, JUICE, and Europa Clipper are designed. Instruments are better equipped to capture dynamic atmospheric changes and identify high-energy interactions caused by such collisions. As we continue our journey into Jupiter's world here on Infinity Beyond, the legacy of SL9 reminds us that the universe is far from static. It's alive with movement, impact, and transformation. In our next chapter, we turn inward to explore Jupiter's mysterious core, its immense internal pressure, and what might lie beneath those thick, swirling clouds.